Hey, what do I have 5?
How are you? Good. Pardon me. John Mark.
Yes.
John Hunter.
Hi.
Nice to meet you. Great.
Thanks.
Thanks, man. Yeah, absolutely. Anything I can do to help? Or,
I think we're just trying to make sure we got everything set up.
Okay. If you need a body, just tell me what to do.
Appreciate it.
Yeah.
Hey, Dan. What's that? Yeah, so you can hear it. Yeah, okay.
It's all coming from here.
Okay. Mute it for now. Actually, I can mute you. Okay, there you go. Okay, now we're live. Mark, yo. Yeah, can you hear me? I'm talking. It's a few seconds delayed. Yeah, okay. Sounds good. I can hear from here. Yeah? We're good, right? Hey Dan, can you confirm that your audio is super? Are your speakers off? Turn off your speakers. Mute. I'm gonna mute you.
Here's this place where the meetup is. Yes.
Now, turn up your volume.
Actually, you can
That's because
John Mark.
he's muted.
The microphone is picking you up.
Oh, okay, okay, that's it.
That's a crazy.
Yeah,
It's a crazy thing. Microphone that just picks up everything.
okay.
Too much power.
All right, we're going to get started in about 5 minutes. Take the time, get to know each other, and then we'll get started in a bit. Okay. So you're back there, right?
You got a box out there on the table.
Oh yeah, it has t-shirts. Yeah, go and bring it in.
We don't have it yet. Shape. You need the WebEx stuff to send it to group. On right now.
So WebEx room.
Group.
No, he's gonna be hanging out. The only people who need WebEx are people in China who need access to EMC.
Oh, okay. Whatever is the.
Yeah, I'll send a. So he can.
You have his email. If you can just.
Yeah, there's a YouTube.
Yeah,
Hang on.
and then later you just got.
Okay, thanks. So.
How are you? Sorry.
Hang on a second. If he goes to. Yes, let me forward WebEx.
Sorry, you got those? Is that today? That's tomorrow.
Mark? Yeah. What?
He took up to you.
Okay.
And then, yeah, sure. You don't mind the meeting? I'm sure.
Yeah, we set this all up and then we're checking it out.
Well,
If you don't mind.
it's a community. You are in the.
Just didn't give me any route anywhere so far.
But if we can't, if it's, then we'll get you guys added onto the campus network. I'm whatever.
Nice to see you again. I met Paul. Yeah. Hi, John. We met briefly with Paul.
My laptop on, it's always on my.
It's there for other meetings and then this also, at the same time. But why here?
I'll see you.
Oregon State University,
Yeah, I know. I was kind of like,
Yeah.
I think they're just more.
So then when they say something, they're all safety.
I can't see it every day. Traffic jam. Hopefully that
Hey,
is-
ready?
Shane is Danny Young.
I listen to
If you go to, so there's an event page. If you go to the CoprHD,
Like 45 minutes of time.
there's an event.
Yeah.
Yeah.
Which network should we connect to? Visitor?
Visitor.
Okay.
And I'll go through all the logistics here in a second.
All right, I'm connected to Visitor, but I can't get anywhere.
You have to log in, laptop.
You can't get through the visitor.
Okay, so,
Nowhere that I try to connect, it wouldn't let me.
to those of you who were here last time but not here in Boston, how awesome is this room? Much better, right?
Yeah.
Especially than the first day. Remember that one? Oh God.
Hey, who did the coordination? That's what you
Shane's the man. If any of you need anything, he's the guy you go to.
including the umbrellas.
Anything. I saw some water
Yeah.
fountains back there.
Share this.
Anybody needs to go? Bathrooms are also like on the other side over there.
At 3 o'clock, they're gonna run out of coffee and water services.
Wow,
Cameras.
nice.
So they.
We rated coffee.
That's
That's awesome. Before we get officially started, I just figure we just go around the room, say hi, who we are, and then we get started. My name is Ura. I work for EMC, and I've been working on the CoprHD project since inception, and really happy. Wow, we get kind of like double in one sitting. That's great.
We have to meet in a whole new building next meeting.
Great. Next one is EMC World, right? We just
Sure, we have a
hang out and go there.
location. I'm Kurt Bruns, work for Intel, been on the CoprHD project for, I guess, about since June when it first went open source.
Yeah.
In development on it.
Ricky Chagan from Intel, been there with CoprHD right from the beginning.
I am Nate Potter, also from Intel. I'm just starting with CoprHD. I have a little bit of experience working in OpenStack Cinder though.
I'm Anil from EMC. I came from EMC Bangalore, working on CoprHD and working mainly on OpenStack.
I'm Piotr, Intel Poland, together with Anil and Kurt, we are working on OpenStack integration in CoprHD.
Anybody who had to fly more than 20 hours goes on this table right here. Just saying.
I'm here.
Okay, this area.
This room.
Good.
There goes like 4 o'clock.
I am Devanjan Sarkar, I'm from EMC, and I was originally the one who led from password controller transitioning into open source. And then now with a good team in place, so I'm back to doing my usual stuff and supporting some initiative. We have a presentation today afternoon. We'll talk about it.
Hello, Ben Perkins, with EMC, based out of Texas, so I definitely did not win the flying competition, but glad to be here for my second CoprHD Summit. Been working on CoprHD kind of from the beginning and through now, so glad to be here.
I'm Chen Liu. I'm working for Intel. I just joined the CoprHD. You can.
Hi. Hi, I'm Amrish, based of EMC Seattle. I work on the corporate community engagement and social media because we who made the image of
Yes, I was going to mention that.
That is a big influence.
All right.
I'm Sean McGinnis, I'm from Dell, and also the current OpenStack Cinder PTO.
Just getting involved in CoprHD, but mostly learning here. Literally just got an install working last week, so.
Sweet.
It's learning.
Thank you for joining us.
Nice.
I'm Lance Albertson. I'm the director of the Open Source Lab here at Oregon State University, so I didn't have to go very far to follow.
Then the units are different.
Oh, we're going this way?
Yeah.
I'm Carlos Jensen. I'm a faculty member here at OSU, software engineering and usability. Not that we have any usability issues here. And I am the director of the Center for Applied Systems and Software, where we partner with industry and government organization open source projects to try to help them out and meet their needs, and at the same time train up students to get the hands-on skills that you need.
Jason Davidson, I am an EMC employee, formerly an Intel employee, and I own the Intel business development relationship for EMC, and was pretty involved in this community.
Hi all, my name is Varun. I'm an OSU graduate student pursuing computer science at Oregon State University. I'm working on the Scale.io driver with my team here.
Hi, I'm Susan. I'm also a graduate student in OSU and also in the Scale driver project.
I'm Taylor. I'm studying computer science here at OSU, and also working on the Scale.io driver. Also.
I'm a graduate student at OSU, studying computer science, and I'm also working with these guys on Scale.io.
Okay, interrupt. Next time you can't sit together.
Why would we do it? 20+ hour flyers.
Will look very mean.
Hi everyone, my name is John Hunter. I work for EMC as well. I'm out of Portland. I'm part of the pre-sales systems engineer organization. So I lead a team of pre-sales systems engineers that help support OSU as a customer, help support Intel as a customer, and a lot of our other large customers in the Pacific Northwest. Yeah, nice to be here. Thanks
From
for
sales?
the event.
He's paying for dinner.
Nice.
Nice.
There's a difference, pre-sales.
Ah.
There's a difference.
This is the promise.
I promise to pay for dinner, buddy.
John's expense reports come to me, so I'll just we're systems engineering, not sales. I'm Dana Young, and I've got the systems engineers across Pacific Northwest and Northern California in the same organization.
Which way direction? Yeah.
This is Roy, yes. I'm Dan Jeffroy. I'm with EMC. Been with CoprHD since the beginning. My team does a lot of the appliance, container, OpenSUSE, the install, deployment, base OS level for CoprHD.
Tom?
I'm Tom Watson. I was at the first summit, and I've kind of been working on CoprHD since it started, and Viper before that, and Viper now. Mostly I work in storage provisioning and some infrastructure stuff like workflows and stuff like vFlex and all kinds of stuff, right? So welcome. We're really glad to see this great turnout. So neat.
Cool. Hi, I am Ritika, and I'm from Intel Bangalore.
Cool.
I've met you guys at the Tokyo Summit. I'm from the data center group, and I'm looking at rack-based SDI controllers. So CoprHD is one of the controllers I'm considering for my solution.
Cool. Who's next? Oh.
Shane.
Sorry, I was trying to. I'm Shane Huddleston. I'm the director of IT infrastructure for the university here. I didn't go far. I went approximately 50,000 centimeters. And then I made a big number too.
I'm Malini Bandaru, and I'm with Intel in the Open Source Technology Center. I've been working on OpenStack for about 3 years.
So I know a little bit about everything.
Yeah.
Jack of all, master of none. And my team and I are all based in Santa Clara, Portland, and Nate's on our team. Chinmay is on my team.
Cool. Awesome. So are you related to Dirk's group at all, or there's a Linux group separate from the open source?
We're part of the same,
Part of the same
open
umbrella.
source technology.
Got it. Okay. Excellent. So yes, I'm the guy in the loud jacket, as always, and my name is John Mark Walker. I've been at EMC for about 3-4 months now. Oh my God. And came out to try to figure out how to make the CoprHD community process work more efficiently and get more people engaged. And I've been doing that for about 15 years with a bunch of startups and Red Hat, and now I'm at EMC. So, you interested? Oh yeah, we have goodies. We can just slice those open, and anybody can get them if you want. Or did you introduce yourself, or no? You did. Okay, you did. So we're done.
Did we miss anyone?
I think we're.
I think we made the rounds.
I think we're good. So first off, I just want to point out that not all of you signed up on the Eventbrite page, which means that we don't have enough food tonight. But hey, but I think we need to adjust our body count for dinner. Yes. Who wants to go to dinner at 7? Keep your hand up. So that's pretty much everyone.
Is it free or is it?
No, you're paying for everyone. Yeah.
We got people from India. I think we got this. Yeah.
Yes, dinner is provided. So we got. So wait. So how many? It's basically everyone, right? I mean.
Who doesn't?
I mean, yeah. Who doesn't want to go to dinner? Who cannot?
I cannot.
Oh, so 4 people cannot go. Okay, so that. Okay, we have just. I think we said 20. So I think that would.
I'm with 45.
Smart man. You've done this before.
Right.
John, you're going to take care of it this time.
Yes.
Next time, the pre-sales guys are going to get the sales guys.
Yes. Yes. Yeah. I didn't know you were coming until I'd already committed to that. But yes, welcome. This is great turnout. I'm very, very pleased. We've got a lot of exciting things going on. It's been a really good year getting this thing started. Not to start things out on a down note, but just to let you know that the number of projects that go from a commercial product to a successful open source project is very, very few. Very few companies have been able to pull this off. So I'm actually very pleased with the progress that we've made in such a short amount of time compared to a lot of other projects that have tried to go this way and failed. We've made significant progress compared to a lot of other projects that I've personally been involved in. The amount of external contributions, thank you, Reddy, thank you, Intel guys. Your presence is so much, very much appreciated. And the same with Oregon State. You know, the fact that we have active contributions from all these different people outside of the original core team, it means a lot. And it's a very good marker for current and future success. So I just want to say that, you know, for full stop, because what we're doing is not easy at all. You would think it's easy, but it's actually, turns out it's very hard because everyone has these preconceived notions of what open source is and how it works, and usually turns out differently than what they assumed from the beginning. So with that little pat on the back, we'll get started. A few logistical things. Like I mentioned, dinner tonight at 7. What's the place?
Big River. Big River?
Big River, okay. So,
about 5 blocks away.
On First Street.
Okay. We'll figure it out when we get to that time. We have quite a few things. We have a few sessions today, a few sessions tomorrow. If you go to the Eventbrite page, it has the most recent agenda. So that will give you kind of the most recent setup, the most up-to-date agenda so far. It will change, and as these things do, because this is a developer summit, and when developers get in the same room, things change. That's the whole point, kind of. So don't be surprised if we end up changing the game as we move along. Note that this mic is live. It is being broadcast as we speak to YouTube. So anything you say here can and will be heard by people outside. Just keep that in mind.
Heard but not seen. We're on audio.
Oh, we can make video if you guys want. I mean, it's easy.
Yeah, so disclaimer, I'm not responsible for any of the things people say. So we get that clear from the beginning. Oh, and anything I say is not necessarily the opinion of my employer. Just get that. And this statement may contain forward-looking. All right. So I wanted to go through kind of where we are as a community and what we're looking for in this coming year. I was at the right spot. No. There we go. What we have to look forward to in the coming year, what's going to be happening, and how we can all jump in together and help. So I'll go through a few minutes of this, and then I think Ben has some things he wants to say about the new technical steering committee, what we're doing with that, the bylaws, and all that good stuff. I'm just basically the cheerleader, so I'll get this over with in the beginning. If you need Wi-Fi information, it's posted on the wall there. It's the visitor network. It should be, looks like a pretty simple setup process, so it shouldn't be too time consuming. Other housekeeping items. Shane, where are the bathrooms?
Across there.
Okay, there you go. And other than that, I don't think there was anything else to, we have a break kind of later. What?
I think we need to know what kind of adapters we need there for that display. I was going to run over there real quick and grab a display port for them.
Or?
We don't have a VGA to make a display port today.
To do what?
Mini display port.
Oh, yeah, if you have a Mac and you're presenting, you may be SOL.
Well, I'm going to go fix it.
Okay, thanks.
I'm the director of IT. All things.
Yeah, well, I mean, hopefully people brought their dongles because it always happens inevitably. Cool. Yeah, just in case people need it. So what are we here for? We are here to build the world's most popular software-defined storage controller platform to have the largest user base, to have the largest base of developer users. To be a platform, to actually qualify as a platform, has to be things that people target as a platform. From northbound developers on the cloud and cloud native side to the southbound developers on the storage side. Both sides need to see Copperhead as something of value in order for it to be a viable platform. And so towards that end, this next year is going to be all about how do we accelerate development on the northbound and southbound side? How do we get all the cloud platforms to utilize Copperhead as the primary way to access storage resources? And then on the southbound side, how do we get storage providers to recognize that Copperhead is their avenue to cloud native applications and orchestration? So that's kind of the whole ball game right there. And that's well.
Oh my God, it's over already.
Yeah, so I guess we can all go home. So that's what we're here for. Does anyone dispute this before I go forward? Because it's kind of important. If someone doesn't think that's the case, then we kind of have to reestablish that. Recently, we had Copperhead 2.4 release. It's the first release where we actually had a fully branded Copperhead. Previous to this, if you downloaded from copperhead.org, you got a bunch of bits that said Viper. And I think it's very important for an open source community to have an established identity, to have an established brand, so that when you download the thing that it says, then you have certain expectations about how it will function, how it will look. And 2.4 was really about being able to meet those expectations and make it a usable thing that people have to buy into the identity, both people core to the project as well as outsiders who come in. Developing identity is extremely important in the formative stages of an open source community. Also, with this release, we formalized the technical steering committee. We have a set of bylaws, and Ben will go into the details there. And we had our first live stream event on December 9th. Did anyone actually catch the live stream of that? Just curious if anyone had the patience to make it through. No. All right, got it. And positively, we had some really good press reception to what we were releasing. There were about 10 articles written about the release. It was actually a really good pickup. We're very satisfied by that. And hopefully we'll see more and more of that as we go forward. The Southbound SDK, we announced basically, as part of that release, we included, a big part of that release was announcing who's participating in the project. And so part of that was the emphasis on the Southbound SDK as a project in and of itself, and the OpenStack integration, another project that we announced. As for the Southbound SDK, it's a great area for outside or non-core project members to participate and to contribute. And so right now we have kind of the first steps towards a Southbound SDK. I think it'll be expected to be code complete in sometime in March or April, in the spring timeframe. And we have, concurrently with that, we've got our OSU guys leading up the project to develop the new Scale.io driver. And that's actually a really important set of work because it's going to validate or invalidate our thoughts about the Southbound SDK and let us move forward with that going forward. So we look forward to hearing more about that later this week. And then the new Scale.io driver. And then it looks like they had that kind of the first batch of code that was ready in early December, just in time for our previous release. So that was very exciting. And I just heard yesterday, and I'm hoping to get a demo of this going either later today or later this week, but I just heard that the first implementation of a Ceph driver has been completed. And so this is by Randy Bias's team, and I'm really looking forward to seeing a demo of that. Hopefully I can get that scheduled either tomorrow or Thursday. That's, in my mind, that's a really good way for us to extend the coverage of Copperhead and win more users going forward. So why do we do all this stuff? I don't want to spend a lot of time on this, but as we move through the process of going from Viper to Copperhead, it's been important to establish identity for Copperhead and to establish a process for going from community project to downstream product. There's not much you have to take away from this, except that one of the markers of success of an open source project is when you have multiple products downstream from it. We're not there yet, but hopefully we'll be soon. Since the release, we've made a concerted effort. Well, first off, when we first did this release, like way back, or when we first announced it way back in May, there were a lot of doubtful comments about whether or not we were serious about doing it. And I think when you look at the amount of effort we've put into the community process, the amount of effort we've made into reaching out to prospective developers and contributors, I don't think there's any doubt in anyone's mind at this point that we are in fact serious about doing this. And every step we take puts us further down the path that we want to go. So everything we've done, from hiring me to all the different pieces of the TSC and the bylaws, going out with the larger story, the identity, it's all about building this larger ecosystem and community and making it larger than it's ever been before, larger than ourselves. There's also, if you notice, a little arrow pointing down to the different ways you can consume Copperhead. That also dovetails in with something I'm going to talk about later about making it more usable and talking about the usability story, getting those case studies out there, getting more, not necessarily customers, but getting more users involved and targeting kind of where are the audiences that we want to reach from a user standpoint. And a lot of well, you are the Copperhead community, so you can vouch for this. But we now have, everything you want to do, you can do from Copperhead.org, from file a ticket to look up documentation on the wiki to pull directly from Git or Git repos to whatever you want to do. That was actually a very important thing to establish. Thanks to Uda, we now have a next revision of the website, so it's even more informative and user-friendly than it was before. So our priorities going forward are, so the diagram right now is pretty aspirational. Not everything you see down there is actually supported yet, but we have either thoughts around doing it or actually actively working on it at the moment. But it's all about, how do we create this open software-defined storage community? How do we build out the ecosystem? How do we make it easy for northbound and southbound contributors to participate, to build this stuff out? And it's going to be about enabling these people to do it more easily, more quickly, and accelerating the progress. So when you look at what we've been able to do in just a few months, it's actually really impressive. I mean, look at all the bullets here that sort of show all that we've done. From the first code drop, and there was a lot of effort that went into that just to get everything in place and in process to release the code in the first place, to the first release, to the first community website that was visible to the outside world, to developer summit that we had in Cambridge back in September, to this developer summit we're having now, to the bylaws, to the TSC, and then the 2.4 release. And this is just, these are just the first steps, and yet already we have quite a set of things that we can point to that show, how viable this is, and with positive prospects for future growth. So when you say future growth and success, what do I mean by that? When you really think about it, what do we want to say at this time next year? What do we want to point to as successes for 2016? How do we want to actually grow this thing? I think it's pretty clear that as the year goes on, we want other storage vendors to participate. We want to see their support built in. We want to see more northbound cloud orchestration pieces wrapped in, integrated in. We want to see a container story, which we're going to hear more about this afternoon, which is great. All these things, these are all very important steps to take over this next year and priorities to establish around 2016. To that end, it's all going to be about how do we enable people to do things? How do we empower them to do more? We need more content. Well, we actually have a really good set of content now around for both users and developers to get started. I think I would put up our content against a whole lot of other projects just in terms of getting started stuff and being able to do advanced things. We're going to be pushing a much larger, much more aggressive social media story. Ambrish in the back is going to be helping them with that a lot. So he's going to be instrumental there. Like I mentioned, the northbound-southbound integrations, that's obviously a huge priority for us. And then usability. Can someone unfamiliar with Copperhead come to the website and get going quickly? And can they be brought to their aha moment within minutes, or is it going to take hours? How do we get that time down so we can get that? Forgive me for using this in advance. Getting that hockey stick of a growth curve, but it's all about making it more usable, more accessible, more consumable, and just building on that going forward. And that's really all I have. Ben, you want to say a few words about your role as TSC Master, TSC Grandmaster? Sorry, Benevolent Dictator for Life, I think is that what we call it?
Exactly what grandiose title. We'll put that forward.
No, hey, get up, come here. Let people see you.
These are highly prepared remarks that I've been thinking about for at least 30 seconds. So it's great that one occurred. All right, so John Mark covered almost everything I was thinking I might cover, so this will be brief, but it's been an interesting adventure for Copperhead over this last year because, from the beginning where he was talking about getting the source code ready, I was involved with that. I was involved in sort of standing up the infrastructure, saying how do we get this closed infrastructure that's all inside the EMC's firewall moved out into the open where anyone can contribute and still have Viper move forward while we're doing it. And so it was an interesting calculus that we've been going through for a while to open up development on a moving airplane, train, I don't know, pick your metaphor. But I think I'm pretty happy with where we've come. And so this is the TSC is sort of the next step. We put the code out there, and then we put out the build system, and now we're sort of saying, okay, now how do we figure out how to drive forward with Copperhead? And so we don't have really any official political organs. I mean, John Mark is helping with promotion and marketing and community development and all the rest, but the TSC is not in that business. We are all people that write code, architects, that kind of stuff. We have folks from within EMC, Tom, you've met here. Bill Elliott, unfortunately, was not able to make it. We've got Reddy from Intel. We've got Shane helping from the Oregon State side. And our mission, as I see it, is to sort of steer, largely from a technical standpoint, Copperhead forward into the future that he's been laying out here for you, and making sure that we make good decisions for the quality of the product and provide guidance to developers and make sure that we can move forward as a community and build a quality product. So he said most popular platform, and that's a good thing to have. I want it to be the best platform from a technical standpoint and usable for customers. And so I think that's, as I see it, sort of our mission to make sure that people know how to get involved, what projects will move the platform forward and steer those in to the roadmap as we go forward. So the TSC, you can go on the wiki, there's a set of bylaws that he talked about, and it talks about the role of the TSC, but largely the community will help drive what the roadmap will be, but the TSC is sort of the referees saying, okay, these are the projects that look like they make sense, and this is where we can slot them in for releases and all of that. And so that as a community, inclusively with, like I say, right now, EMC, Intel, and OSU representation, but that is not set in stone. Every year there'll be elections for TSC members, and the community is welcome and encouraged, and we hope we'll get involved and more vibrant all the time, and even have more organizations joining in. So we're looking forward to working with the entire Copperhead community going forward this year.
What was it like getting the bylaws approved? How many different iterations do we go through on that?
I was not actually in the first iterations of the bylaws. It was largely completely transparent to me, but it went through many revisions with different executives, different directors, different whatever, back and forth for several months before I even plugged into it. And then in the third quarter of last year or whatever, there were, I know we went out to Intel and went out to OSU and...
What's that?
About 30.
At least 30?
Yeah.
Okay, yeah, so it was
March of the year.
Right. So yeah, it was an interesting process trying to work through, obviously EMC, Copperhead is a first for EMC in terms of, we have a few more now I think in open source, but Copperhead was the first major case of EMC releasing open source, and so there were a lot of internal legal things that had to be dealt with and things that had never been done before, as well as trying to go out to the community and go out to others and try to figure out, all right, what's a community process that works and will make the community feel engaged and empowered.
And speaking of legal, I am not a PowerPoint expert, so I could not figure out how to remove the EMC logo and the all rights reserved thing on the, but I figured someone who's, what's that?
Yeah, we'll disregard.
So, but I did try.
A screenshot and paint.
White box over.
Anyway.
I can help you.
Yeah, I can help with that too.
Okay, cool.
So yeah, I mean, we're you know, there's no doubt that EMC is a big part of this community right now, and that's not a bad thing. But we're looking for other people to grow into that realm as well, and we're looking for technical contributions. We're looking for leadership. We're looking for all of that to help guide Copperhead, because definitely the energy for fresh ideas and fresh direction can come from any of you. So. Any questions or?
So John, Mark, in your slide you said we want one big partner among the 5 big or something.
At least one.
Which are those 5?
Honestly, I don't care. I just.
No.
Who are the big 5?
Oh, sorry. Sorry. You get stuck in this industry and you forget that other people are not. So companies like NetApp, Hitachi Data Systems, IBM. There are a couple others I'm missing. I'd love to see. Now that we've started it down the road of a SAP driver, I'd love to see Red Hat pick up the ball and start contributing from that direction as well. So I'm probably missing one more, but who? Yes, HP. Thank you. So those types of companies. So far we've had some discussions, and they'll continue, and hopefully we can keep driving that forward. But that's the level of company I'd like to see as a partner this next year.
It's kind of driving the story that, obviously Viper started out supporting EMC arrays the best. We had NetApp support. We've added in some Hitachi support, but we know our arrays the best. We can write the best drivers for them. And it's honestly a challenge to buy all of the other hardware from all our competitors, and if so, be able to write all the best drivers for it. And so the best support we can have for a large array of storage arrays is have people from those different companies contributing and seeing, I've got to have a driver for Copperhead, or I'm being left out of the storage picture. And so that's really where we want to see is these guys wanting to be part of Copperhead and feeling like it's important to support that for their customers.
Cool.
All right.
Anything else?
Other questions before I think we're going to dive right into I think the agenda still says southbound, right?
I think, yeah, for at 2 o'clock. Ura, do you want to, you have any remarks you want to impart?
Thank you for coming.
It feels weird to welcome you all here since I'm not from here, but I'm glad you're all here. I'm grateful to Shane for playing host along with the rest of the folks here from Oregon State. So yeah, we hope to have I mean, we've got a number of topics on the agenda for discussion. There'll be some presentation, there'll be some demonstration, and there'll be a lot of discussion. And if the agenda gets totally derailed by discussion, but it's good discussion, then we won't have failed. You know, in other words, we set up the agenda as a TSC and as a group to try to be interesting to the community, to provide information to the community, and also to learn. And so anything that yields that result will be success, at least in my opinion. And so feel free to jump in with questions. We're not trying to leave anybody behind here. And so we're still learning how to run an open source project. And so feel free to help us learn.
Yes.
Including by criticism, hopefully friendly. But anyway, no, we're looking forward to this. So,
you ready?
Yeah.
Do you have any introductory comments you want to make about the TSC and why you're here?
No, I mean, I think.
You gonna come up ready?
Get up. Shane, you're next.
This was not planned.
Yeah, exactly. No, you have almost as much notice as me.
No sympathy for me. So, I think the just stepping back and looking at it, I think in 2014, Intel and Oregon State University, we spent a ton of time to figure out what exactly we mean by software-defined storage. So let me step back a little bit. So we spent almost a year in Intel to figure out what do we mean by software-defined storage. And convincing all the groups within Intel was a daunting task. So that was the first step. Out of that
after you got
effort,
involved with CoprHD?
it's long before.
Oh, okay.
So sometime in 2014, 2013, late 2013 or so. Out of that effort, we defined what SDS framework is supposed to be. Then the question is, it's not just Intel. We have to work with all our partners to make sure that the industry as a whole agrees to what we mean by software-defined storage framework. So myself and Shane, we actually spent quite a bit of time going outside, promoting software-defined storage framework and what do we mean by it, what do we need to do in the industry, and all the good stuff. I think sometime in 2014, late 2014, we had discussion with EMC. And we met with CTO office, we met with Viper team, and lots of heated discussions on it does not make sense to open source, right? So Jason actually was in the middle of the discussion too. So a lot of heated discussions on why it doesn't make sense, why we were pretty much on the wrong track, all kinds of things. But towards the early part of January, things have changed completely. We went to Boston right around this time last year. Pretty bad, weather. Kurt was saying, hey, we always tend to pick up Q1, which tends to be pretty bad. So it was, in March timeframe, we talked about what, so EMC team wanted to actually share their ideas and what they wanted to do, Viper team specifically. And outcome of the discussion was, hey, we are going to open source it.
Your dates.
Oh, here are the dates. I don't know if you can actually project it, but this is so September 10th, this was the idea of one? Was this the idea of one, September 10th?
I don't want to steal your thunder. So,
okay.
I can talk though if you want.
So September 10th was when the Intel Developer Forum, you guys announced that you guys are doing your own software design, storage control, and open source. By December 2nd, we had our summit where you guys talked with EMC's
So that was the software summit in 2014.
And that was in Arizona.
Yeah.
January 29th is when EMC made the decision to go all in on this.
Open source it. Oh, wow.
And March 5th, 6th was our kickoff that you guys had out in Hopkinton.
Yeah.
April 8th and 9th, we had our second follow-up in Arizona.
A lot of debate around the
licensing
stuff.
A lot of revisions
so
of
that's where the
stuff.
30 plus revs actually showed up, right? So that was the beginning of debate.
May 5th was when the code went live. The announcement was happened on May 5th.
And June is the code.
And the code went live on June 5th. So it was 3 months from the decision to do it to actually code live.
Yeah.
Which is pretty cool.
This was all planned. It looks like he prepared for it.
The slides were made 3 years
I know it's awesome if you do them after you do that.
Exactly. So, yeah. So I mean, 2 years of work actually went behind the scenes, both within Intel, with, I think in 2014, I probably shared the SDS framework with 50 or 60 different customers. Last year, I switched completely from very vague, abstract SDS framework to, hey, here is a real implementation, and it's all about Copperhead, right? So we talked to a lot of customers about Copperhead, and what does it take for us to actually do the POCs, and how do we work together? So the goal was, how do we bring in more and more developers as well as the end customers, plus ISVs, OEMs, and ODMs into the community. So a lot of focus around, going into the industry, promoting Copperhead, and trying to get pulse on what they think about, Copperhead, what is good, what is bad, what do we need to do differently. So out of those discussions, in fact, in OpenStack Vancouver, we had a lot of discussions with NetApp and few others. Based on those discussions, so if you were to look at the history of the licensing model, it started off as MPL. Lot of concerns about the licensing model, ended up actually changing to Apache, right? So, but it was all about listening to the feedback from the ecosystem to figure out what is the right thing to do for the community. And one thing I want to say is the EMC team has actually changed quite a bit from the perspective of extremely proprietary, homegrown culture to really embracing and being part of the open source way of doing things, right? So we are in here for a long haul, but things are going good. Looking at the first developer meetup, I was telling Shane, hey, look at the crowd. It is unbelievable. We had only a handful of Intel folks and a couple of OSU folks, and you can see that the crowd has pretty much expanded quite a bit from the contribution perspective. So it's a good thing.
Absolutely.
And even one thing to mention is the fact that even inside our own companies, like, oh, but there's a bunch of people from EMC and a bunch of people from Intel. Yes, but you have to remember, even inside the companies, just that growth into different business units and organizations, etc., and all of them starting to contribute and being part of it is huge in a lot of these big companies.
So maybe one of the things, just adding on to the amount of friction that goes on within a company, even after this whole SDS framework and Copperhead and all that stuff, lots of folks internally talking about, hey, why should I invest in Copperhead? What's in it for me? So maybe Malini, you can actually spend a few minutes on the 6 to 8 months of effort that went on behind the scenes to convince the Open Source Technology Center, who is primarily focusing on the open source enabling solutions, including OpenStack, Linux, and so on. It was not an easy thing for me to just walk in and say, can you give me a couple of resources? It's not easy. For someone to actually put in resources and really contribute to it, it's not a small thing.
Yeah. So of course, I mean, Reddy's so friendly and to work with him. That's the only reason. Huh?
It's hard to say. No bribings involved.
But the thing is, like, there's so many layers. There's a data center group, there's the open source technology group, and the software services group, there's the data group, whatever. And then they'll say, hey, how many storage operators do you need? And typically, how brownfield is it? And how heterogeneous is it? Do I really need this software-defined storage controller type of thing? So every point there's these questions, but one thing I do want to say, the Open Source Technology Center at Intel says there is going to be this. You don't know which is a necessary product. You don't know among the end products which one will be a winner. Maybe we have to invest a little everywhere. So we said, let's start small, let's put 2 heads, and then let's see how this goes. If it takes off, we're going to have another 8 people all together. We started with 2 really bright people, Chinmay and Nate over here. But that's how we're looking at it. And yes, Reddy is a very important part of it. He's so friendly, easy to work with him.
That's all you have to do.
That's all.
And you know what? I can ping him on IM and he doesn't give me like, don't bother me. He answers every question. That helps, It doesn't blow me off.
It blows me off all the time.
But the boundaries in the company are high, even though invisible, and it's a hard sell.
Yeah.
And we also have a pretty significant team working in OpenStack, so we wanted to see where it fits in with respect to Cinder. Does it lie under Cinder? Does it lie above Cinder? And then as a hardware company, we're just aware it's going to be software-defined infrastructure. There's going to be a controller for networking, for storage, for compute, and for security that cross-cuts everywhere. And how do you control the controllers is also going to be a thing there. So we're seeing that big picture, and like Ravi said in 2014, we were saying, how is this landscape going to evolve? It was obvious there had to be a storage controller.
Cool.
So I'm here because of Reddy. They're here because of Reddy.
Thank you very much.
Thank you. I can go home now.
You're buying dinner.
Shane, don't think you're getting off that easy. You put in your 5 minutes. First of all, stand up.
It's a little easier from our point of view. I think I think in like Reddy's saying, in like 2013, we had looked at kind of at the landscape and decided that this is what we needed. We needed something in this space, just for our own use in university. We have a lot of legacy systems. We have a lot of stuff that's nothing is the same. If there's a vendor that makes it, we probably got it. That's just the reality of our world. And so for us, it's been something we've been after for a long time. Like Reddy said, we've been working with Intel, kind of trying to figure out what that vision is. What does that look like? From our standpoint, it's pretty operational, though. It's just, I want it. I need the thing, So that's why we're here. Because nobody was making it, and I got tired of talking about it. I don't know how many conversations that we had with folks where people said, why do you need that? So I need it. I wanted it. Let me explain my data center stuff. That's the reality of my world. Technological refresh. Doing migrations between generations of product. All this stuff. It stinks. It's no fun. And right now we have way too much technical expertise from the storage layer coming all the way up, and needing to be involved in all kinds of decision making that just should not be there. It needs to be abstracted. And so for us, it's just been something we believe in. We want it. So we're trying to make it. We got on board real quick with CoprHD. It's the only game in town, in my opinion. There's some conversation about OpenStack. Should it be an OpenStack? I'm absolute huge, fan of OpenStack, but that's not what's in my data center. I'm not 100% OpenStack, so I need something that's bigger than Cinder. That's the truth. That's for us. I got VMware. I've got all kinds of stuff. So that's why this project resonates with us. That's why we're here. That's why we'll continue to put more and more resources into the project.
Cool. Thank you, Shane.
I have a quick question.
Oh, please.
Yeah,
sure. You don't have
Maybe
to.
1 minute later, I will jump. Is this thing about having different kinds of storage a university thing? Because back in my grad school days, we got freebie, alpha machines. Like, yes, we take it. It made a grad student's life. So, is this like regular industry or only maybe academic institutions?
That's a good question.
I think, so just from my own personal conversations with many peers, other.
Standard.
It's okay. Well, no, this is odd.
Meetup is not supposed to be too formal.
I know. From our conversations with our other folks in the same field, other academic institutions, very similar problems, 100% consistent. A lot of change over time, especially when we get into things like research. So right now we've kind of started, coming from, proprietary systems, but what we're interested in, which is a whole bunch of non-proprietary systems, things like Ceph thing is super exciting, because of the way grants and stuff have worked in the past. People kind of, like you said, they get a hold of stuff, they hold on to it, and it accumulates over time, and we need some kind of way to answer the question, what does my storage look like? Right now, we've got islands everywhere. My sense of talking to folks, candidly in other groups is that the same problem exists elsewhere, not just academics, not education.
I mean, I can add a little bit of color there if it would be helpful from the customer base in the Northwest. Yeah, so we, just to add a little bit there, so I agree. There's one of the things that we're trying to address with all of our customers in the data center is just complexity, right, in general, and complexity at the storage layer, especially in the storage layer, because to your point, it's the digital assets of the company or the institution. There's high risk with moving and migrating, and so we're trying to minimize complexity and minimize risk all over the place. Most of our customers are trying to do that. So one of the things that this solves for them, right, is the complexity across platforms. There's another element in there that we have some other technologies that help with some of the migration pain points, right, moving from platform A to platform B or between two vendors' platforms, called vPlex. On another axis, though, we also have really large EMC customers that have really large, sprawling EMC install bases. And so from that standpoint, the complexity comes from a scale perspective and numbers of arrays, and not so much sometimes from the different vendors of arrays. Either way, it's still complexity, and either way, this software layer, this abstraction layer between the host environment and the storage environment provides, a great value, right?
Well, I think
so
that's a foundational thing, because I didn't mention it earlier, but one of the things is not just managing that complexity, but it's providing the foundation for what we want going forward, which is tooling. Like, how am I supposed to making it smart?
Right.
Like, I want to handle movement of data, aging of data, or, how am I supposed to write, that tooling? We have historically written it for each vendor because everybody's got an SDK. Not even the vendor.
Right.
Products within the vendor line have their own APIs. And so we end up having to do this, over and over and over. So in my mind, it's a foundational piece as well for the automation that we want. The automation kind of, I guess, introspection that we're looking for.
That's the point I want to hammer home this next year. Like the whole you can automate your entire set of storage. Like that's.
Yeah. I kind of want to push on that too. I've done many customer calls about Viper, automation, and so forth, and they're struggling. You'd be surprised. Many of our customers are multi-vendor, and they struggle with how to make those interoperate. They struggle with complexity, standards. Some of the complexity is in best practices. Part of what we try to do is go out and figure out what the best practices are and put that in code so that the people doing the provisioning don't have to be experts in the best practice of every individual array that they encounter. And that happens, they might have 10 different kinds of equipment. And then the other thing that we try to reduce complexity is in complicated sort of, I would call it multi-layer provisioning, where at the bottom you might have arrays, and then you might have a protection system like a vPlex or an IBM SVC, and then you might have some kind of replication piece of equipment like recover point. And by the time you provision all those together, you've got a provisioning workflow, if you will, that takes 50 or 100 steps. And it's just very complicated for customers to do.
Cool. All right, I think unless anybody has anything else I want to add to that, I think we can safely move over to the next thing on the agenda, which is Southbound SDK. So, should I invite getting into the Hangout? Because it sounds like, why don't we take like 5 minutes? Shane, is there a place to get water around here, or?
There's like a table with some stuff around there. Was that for us or someone else?
No, not us.
Just look, read on the wall whatever it says.
Sorry, we kind of open source it.
All right.
Open source. No, there's never water.
Time out.
Water fountain is like straight that way.
Okay. So let's take 5 minutes. We'll get set up with these guys, with Evgeny, and then take a break. Come back here, and we'll start. So we'll say 10 after.
So the thing you saw dropping out was my personal.
And as you,
I saw that.
as the day continues, whatever, in that box are these T-shirts.
I think that's all we need.
So if you want
These guys are going to
go
start
grab them.
first. They've been working with
There's many different sizes.
Students will start. He's going to do the second half.
Okay.
So as
Wait,
far
who's
as I
going to do
know-
the second half of it?
Oh, okay. South Carolina. They were going to talk about this. Skill
Yeah.
they've been working on. They were going to give it to them for
Okay.
7 o'clock. Okay. South Carolina's okay. It's me. They want to tell them.
Yeah.
Yeah. They really don't. So my answer is just can't say one of those is skill, one of those is South Carolina. When I listened to the flow last night, I heard them talking. I was like, yeah. This feels like this is way too far like you need skill out to it's dependent on the new South Carolina kit. Right. And vice versa. We've been working with each other. But as far as presentation,
Okay. Very cool.
Oh yeah, please. Yeah,
I need to wait. Turn this guy off.
Hello?
Now you're going to share. Oh, I need to mute you.
discover the storage system, and the block operations, which are for managing the storage system. The discover functions populate the registry with the connection parameters, and then the block operations use those connection parameters or pass them to the Scale.io REST client factory to get a handle for the REST client, and then make requests to the Scale.io REST client. And after we implemented this, Shajin tried to deploy, and she's going to talk about some of the challenges that she faced with that process and the steps that she took.
So for now, we just use the manual deployment because the automated one. Okay, so like before we actually try the deployment, we will need a working CoprHD with the support for sourcebound SDK, which means is the sourcebound SDK UW branch. And then we need to build our job file, modify several configuration files in order to enable the new driver. Then remove the old RPM, review the RPM, and copy the job file into the specific directory. Then add the job file name to the class path, and raise down the whole service. Actually, each step is problematic. I can't cross problems from like one by one from each steps. We will come back to this to talk about the problems for deployment and the related problems later in our discussion session. And I think it's demo time for Warren.
Thank you, Susan. We mainly need to discover the devices using the CLI command.
So the interface uses CLI or is it REST API? So for the scale IO?
Yeah.
Are you guys using CLI based?
The REST API.
REST API, right?
UI for this haven't ready yet, so we need to use the CLI to
It's
perform the discover using our driver.
Oh, this is the CoprHD scale.
Yeah.
Now I was talking about your driver implementation uses completely the REST API.
Yeah, REST API.
Interface
use
for scale IO,
yeah,
right?
yeah. So first I do the authentication to the scale device. Oh, it's okay. I don't.
So he's now authenticated with Viper CLI, CoprHD CLI, actually.
Every time someone says Viper, they have to put in $1.
But it says Viper. We need to change the CLI.
From
the back.
Stakes are high.
Since I traverse both the worlds, I have not going to pay.
So you can put here and take out there. I like that.
By the way, live view looks great. You can see everything there, so that's your sign.
Demo both lights already.
So while that is going on, you guys can actually do a Q&A if there are questions.
Yeah. Okay. Any questions? Also, one thing that I kind of skipped over was our current status. We have the discover functions implemented as well as the snapshot and clone.
Yeah. The pull request is ready there.
The volume provisioning is in progress, so that'll be done soon. And what we have left to do, we should complete in 3 to 4 weeks, and that includes what does that include? The export, right, and clone operations. Yeah. We expected, or we had anticipated, to be totally done with the driver today, but we had some unanticipated challenges with our schedule, so our expected completion date is now 3 to 4 weeks from now.
So how can we do snapshot if we don't do provisioning?
Oh, so I use the CLI to create some variables in the CoprHD, then test with these variables.
Oh, I see.
Yeah. And the second one is the second row which shows the P domain, which is actually discovered using our skill.io driver.
This is live?
Yes.
Yeah. So you can see the pools for that particular storage system.
So for the scale IO stuff, did you guys use the Vagrant images? Or,
yeah, we use the Vagrant images to create the skill.io devices.
Yeah. Thank you.
You're welcome.
So we have one pool over here, the pool 1, which is in the skill.io device. And these are the ports that have been associated with that. We have 3 ports associated with the skill.io device. So that's pretty much it.
Are you creating the network and discovering the hosts and all of that stuff too?
Sorry?
So in the old Scale.io driver, when you discovered it, it would also automatically basically create the network, and it would kind of discover all the nodes as hosts. Is that also happening now, or
Yeah, you can
are we changing that model?
see the host.
So these are the scale-IO hosts in the discovery?
Yes.
It's there.
Yeah, it's there.
And I've always had misgivings about.
Yes, because this is use the same background file, so the scale cluster is the same. It's just a different location. So the pros and post results have the same.
Host will be required when we do the export.
Right.
So I don't think they've reached that stage yet, right?
Yeah.
No.
So when you do the export has to be detected by on the host side on some Linux machine, right? On that machine, you need the scale-IO data client deployed.
SDC.
SDC has to be deployed. So
Right, so maybe there's a discussion here.
In the background images, there's SDCs installed.
that is outside the scope of the drive.
Maybe that this is an area we want to discuss further later on if there's a chance to improve it.
Oh, look at that.
I think as an SDK, it doesn't make sense to add host discovery as part of the
Exactly.
southbound SDK. That should be
Right, that's what I'm thinking, and but the current approach is kind of weird.
Yeah, that's
with the way it does it.
Well, because the driver presently in the native model is not insulated in any way from Viper, a driver can do anything.
Right.
But when you have the driver that's behind the southbound SDK, then there's a more deterministic set of operations that are supported. And so, think about that.
So what's the current flow with the host discovery? How does it happen?
So for everything else,
you would have SDK, southbound SDK in the mix. How will it happen?
So here's the thing. So host discovery for every other case happens directly between CoprHD and the host, and that's it. But for scale-IO, because scale-IO has its own way of communicating with the host, right? There's a little driver that you have to put on the host in order for the host to be able to see the storage of scale-IO.
That's true.
It's like a client thing,
yeah,
right?
That is true even with Ceph and
Sure.
cluster.
Yep.
May not. I don't know about the cluster.
So the way that it's happening today is CoprHD goes talk to scale-IO. Scale-IO tells it about all of those hosts that are out there that can see it. And then CoprHD creates a host instance for each one of those. And it also creates a network, or what CoprHD understands as a network entry. And it puts the ports for all of those hosts and for all of what it considers to be the storage ports on the scale-IO side.
Southbound SDK has to have host-related functions too.
If I don't, that's my question. So
What does it have?
that's where I think we need to talk about.
Southbound SDK, apart from dealing with storage, has to deal with hosts too. If there are protocols like scale-IO, Ceph, etc., which are slightly
it's not
iSCSI or fiber channel
some
or
setup on the host.
Right.
Unless we expand on the host side to be able to discover that kind of stuff, right? So that you could then say, so I got these ports from the equivalent of ports from the array, and then on the host, when you do a discovery, I detect that this host has the client for scale-IO, and then say, oh, okay, so they connect to each other.
So how does it work in the current driver model? So you have a scale-IO instance.
Yeah.
You provision the volumes. Now you want to attach a volume, let's say, on one compute node. For you to attach a volume, you need an SDC on that compute node. Does Viper do that today?
No, Viper doesn't install the SDC. What he's saying is that the native Scale.io driver leverages the fact that Scale.io knows what all the hosts are that are attached to it. And so that driver, in addition to discovering Scale.io, creates host entries in Viper's database representing all the hosts that Scale.io talks to, and also creates the virtual array network entries that show this host can talk to this array.
And the reason is you already installed the SDC on a set of compute nodes.
Right. The assumption is that the Scale.io
now there is an argument to say, well, maybe that's something that we should do. Maybe you should be able, because the problem is it introduces a scenario where you have to know outside of CoprHD that that host can see that scale IO in order to even go in and say, I want so much storage of this kind to that host.
Yeah.
Otherwise, it'll get a failure.
Exactly, but with Anil, right? So it doesn't make sense to pull the host information from Scale IO. While it may work beautifully with the Scale IO instance, it's not going to work with Ceph.
Yes.
Ceph has no clue about the clients. You can basically install Ceph client runtime somewhere and start consuming them. It has no clue. It doesn't keep track of it. I suspect it will be very similar with cluster too.
Yeah.
So
Maybe this is an opportunity
yeah.
to think about it at least and decide do we want to make because like you said, it's work that's going to be used in the future for Ceph.
So who is capturing the ARs or minutes?
Huh?
Who is capturing the minutes?
Minutes. It's all on you project. We're talking about.
So you're going to listen and capture there again? Convert it into speech to text and then see
I
then automatically dish it out to the right
think
person.
to do it southbound, one of you guys should note it up.
Let's start paying attention.
One thing I was thinking is instead of each Scale IO or other storage device knowing about all possible clients, it's better to have a layer of indirection. The clients know some controller's address. The controllers know all the storage addresses or ports or whatever. So then you can always connect them to this.
I think the key thing is how do you know which ones are the compute nodes and whom do you tap into to figure out the compute node. So if it is OpenStack, most likely you can actually go to the Nova and pull all that information. If it is VMware, you can probably pull that information from vCenter. But the challenge is how do you parse it out and say some of them are not really compute, but rather just pure compute versus some of them are used by storage nodes, right? So, but in general, the goal is to figure out if you can tap into the existing repository and then build from there as opposed to you launching a massive discovery to figure out on your own.
For fiber channel, things are easy.
Because you don't need anything on the client side, but because the emerging scale-out infrastructure.
Likewise, for iSCSI things are easy, but our NFS things are easy. But beyond these three protocols,
you need
when you have proprietary protocols, definitely, we need an ability for the driver developer to do something to get the end-to-end, provisioning working. And that could be a completely proprietary thing, which is like optional. If you are writing a driver for fiber channel array, you can leave those things as not required.
Okay. This may be a very stupid question, though. When you do export to a compute node, would it make sense to actually bootstrap some of the compute runtime for a given storage backend to work seamlessly?
No, why? I mean, in the majority of cases, that may not be required.
You're just talking about having the capacity. If you need a client installed on the host in order to connect, have Viper do it, or have CoprHD do it. And that's a valid question. I mean, like I said, in the case of fiber channel type stuff, you don't have to, but in some of these other ones that we're moving toward, you might. And
because the exporting is essentially bootstrapping end to end and making sure that the whole connection works.
True.
That includes the runtime software exists and set up. Yeah. As opposed to assuming that there is a package and we are just configuring.
Because the problem is if you don't do it, the fail states are ugly. You all of a sudden start trying to export the device to a host, and it's just you can't really get to it, and you start getting weird errors.
And you don't want.
Right. So I put it in the parking lot, and then any ARs would come out after we talk. That's another thing I forgot to mention earlier. Usually, we just start writing whatever comes up.
Not as part of Scale, as part of southbound.
Sure. So I'll fix that. That's fine.
Because that makes it more generic.
Yes.
And we don't want to cut into Evgeni's time too much, but there are a few things that we wanted to get your feedback on.
Okay.
They were things that were challenges for us and thinking about future developers who might not have the connections and the support that we had. We thought we might bring them up as areas for improvement.
There are three major difficulties or challenges we are faced in these 3 stages. So we will discuss that.
Yeah. So during the design phase, while starting the project, it was kind of a bit difficult to understand the terminologies and such as the similar kind of protection domain ID, the native ID, everything is kind of similar. So understanding this kind of terminologies at the starting and the kind of architecture, it was kind of a bit difficult. So going forward, if kind of documentation, which would really help for the future developers to have kind of.
Question on that one though, with the existing wiki documentation, where do you see the gap? Just look at the current state of documentation that exists with wiki. Developer-centric documentation, not how to use CoprHD, but rather how CoprHD is built.
Like how to build CoprHD.
Architecture document.
If you were to look at the architecture document and the flows, all that stuff, for a new driver developer, where do you see the gap?
So maybe design was a bad word choice. It wasn't really the overall architecture that was confusing, it was the terminology. So something would be called
like something would be called protection domain in ScaleIO, it would be called system ID in somewhere else. So for like the most time we spend on this will be understand the whole thing. We read through the SDK specifications. There are terminologies and their descriptions, like not much description there. And to figure out what this thing map to which thing is hard for us. Because we don't know what it means for CoprHD as a device label and what it means as a storage name when we come to ScaleIO.
Yeah, that's a very common problem. It's the secret sauce of storage, right? So what I've been thinking of is building a sort of visual dictionary where you have the concepts as CoprHD system, and then maybe a table underneath where you then say,
that would be huge.
On Vmax this means this, on VNX this means that, on ScaleIO it means this, something like that, and then sort of like cross-referencing back and forth, full of hyperlinks everywhere.
Yeah, that
so it'll be even just as confused, but at least it's documented.
Yeah, that would be really helpful because.
So that, that's a good point. We need that.
Okay, give an example. I'm still struggling. When you say the storage uses certain terminology, because see the thing is, here is my view. Somewhere you need to have some common terms and verbs that you can actually latch onto to develop all the drivers. So there is always that challenge of mapping what it means to the driver versus what it means in the southbound SDK interface layer. But
so like we have a couple of models in SDK. We got storage system, storage ports, like for each specific stuff. And
systems, pools, and ports.
Yes, like this is an example. Then we need to like use the REST client to get the information we need from the ScaleIO. And somehow we need to assign this value, this data into populate all these modules, right? And we got all those stuff. Which one we should point to here? So there's storage name and device name. It's all about name. Which one goes to which?
Well, so what I'm hearing is, one thing is you need to know, or the documentation of the SDK needs to very clearly define each field of the data model. What is it supposed to represent? And that, if there's not enough documentation there, then that's a great area for you as basically sort of the beta testers of the SDK interface to comment and say, okay, these are the areas we were confused. Either point out what needs more documentation, or you can submit.
Then I can help you. I can help you find the answer. But
So that totally makes sense.
Point
that totally makes sense. But if I am the storage system guy, I should know what exactly I mean by a storage. So if you're writing a ScaleIO driver, you are not expected to write a ScaleIO driver without knowing the ScaleIO internals. By nature, you are expected to know what ScaleIO driver does, how you can actually use it programmatically and consume it. But when it comes to bridging that gap with the southbound SDK, you need to figure out what exactly pool means in southbound SDK so that you can take the pool in ScaleIO and map it to the right construct in the southbound SDK. So the documentation has to be there in the southbound SDK.
But then
Yes.
ultimately, there's a step of
But there is a
understanding the
bridge.
domain enough of your driver to map it onto that
Exactly.
SDK.
And then when you do it, you map it and kind of make sure that is documented for.
That's where showing examples helps, because then people can be like, oh, that's this thing over here.
Yeah, another example will be in the
Protection
protection
domain.
domain, because it will be the system ID for the storage system. That, because this name is totally different. Yeah, if you don't have a clear definition of this, we don't know this, because in SCAI we also have a system ID. Why not this system ID being a system ID in the SDK?
Yeah. So it sounds like there is a need for more clarity and
more
descriptions around the southbound SDK terms and taxonomy.
There's a need for a general taxonomy,
Yeah.
period. I mean, I think a storage taxonomy would be extremely helpful to a lot of people outside of the context of this room. And if we did that, you know, marketing guy, I think of clicks and SEO and people coming in, but, you know, disregard that. But regardless, I think it would be extremely helpful.
Do you want to talk about deployment?
Yeah, implementation.
Implementation. Okay, we had some challenges with the setup too, and one of the suggestions we had was maybe some kind of template that would define the file structure for a driver and include some of the utilities that we used and some of the base classes that were provided to us. If we wouldn't have had the connections and the support, we would have been writing those on our own. So it would be good for those to be consistent between drivers from the CoprHD perspective, and then from the developer perspective, I don't want to be writing code that already exists.
So having a visibility into the existing sample driver somewhere, is that what?
So
we need to
that
be
basically
addressing,
means
or?
because for us, we don't really need to run the SCAI REST client because it's already supported. It's already finished by EMC. We just take their module. But for another third-party developer, they need to have their own REST client. They need to have their own like factory. So if they need to write this from scratch, there will be a lot of work. But EMC already have the base REST client ready, have the error handling ready, and have some service utils. So if they can provide this code to the developers, it will be a hands-on, will be easier.
So it was not provided to you guys, or what's the problem?
We have been provided for the future developers.
It was there, okay.
Yeah.
Okay, now step back and look at a different storage packet. Let's say I'm going to write it for cluster. Write a driver for cluster.
So if
solid fire. What is needed?
So first, we don't need like each driver has their own error handling. We don't need each driver have their own based REST client. And we don't need, they all have their own, like some service utils. Like it's all common thing we're all gonna use. In the functionality gonna be the same. We don't need to write it from scratch.
That's true though, but okay,
But
I'm trying to
this will
parse
be
it to figure
something-
out what needs to be done
So-
for the new development. That's the reason why I'm asking these questions. So let's say if you're writing a driver for the new backend, storage backend, and you have a REST-based API interface, you could have potentially guidelines saying that, hey, if you have a REST-based backend, and here is how you write a driver interface. That's one model. If you say you don't have the REST-based interface, you have a command line. Here is how you actually write an integration layer for the command line-based storage backend.
Yes.
Yeah.
That will definitely help for new developers coming on board for the new backends that may not have everything in REST-based and that may not have all the bells and whistles associated with exception handling, recovery, and all that stuff. Is that what you guys are recommending, or am I off?
Yeah, that's what we were thinking.
It's kind of template where all the base
Like based on
functionality is there.
different approach.
Okay.
If you have a REST client, you can have the basic REST client modules ready, and he only need to implement the specific functionalities, not like base stuff. And if you use CRI, we can have the CRI basic stuff ready. So it will be just lower the time,
Yes.
and complexity.
Yeah, the implementation time will be much faster.
Right. Good point. Yeah.
You want to talk about the deployment?
Okay. So I actually start deployment from last week. So there's not much time for me. So we don't have the integration test ready. So as I said earlier, each manual steps are problematic. When I finally solve all the problems and get to the point that I can test the discovered system, I'm so excited to open the user interface. Okay, there is a storage system there, and I click on the pulls and ports. There's nothing so up. So all I can do is just go back to the controller service log and read through the thousands, like millions log, lines of log. And the only thing says there is like, first, you start discover pulls, no pulls returned, nothing else. And we don't have the test there. We don't have effective debugging tools. All I can do is just go back to the code, add like a log, extra log. Then do not rebuild the job, redeploy the driver, discover again, read the log. Again and again until I found the problem.
Yeah, it was kind of a tedious task because you need to insert some comments in the code line and you need to go on through the log file again and again till where the integration test has come up. So it was kind of a bit difficult during the deployment time.
So
the problems were actually in the driver code, scalable driver
the
code, or is the above?
problem is how to test the driver when our driver is ready. Is there like, what's the more effective way to do this? Do we merge our driver into Aragonese branch? Then like someone write the integration test to test, or there's other way? So now we don't have a way to test. So what I did there is I deploy and perform the functionality and read the log. It's really not fun.
I mean, we may need a test harness that just engages right at the SDK level to where you could test one of these drivers without everything else. I mean, obviously some of it's needed, but I don't know, that's a good.
Yeah.
What is the good way here?
Probably we need kind of we can cover some of this here, but probably we need sort of a post-mortem on driver development that we can get Evgeny and you guys and some of the rest of us in a room together and say, okay, how can we make the second driver easier than the first one was, and what new infrastructure needs to be built, what new documentation needs to be written, kind of go through all these steps. So
I think it will be good to pull in the Ceph, whoever is writing in Randy Byers team, pull in and get some pulse on what their experience is, and then maybe compare and contrast and see what we can do better.
I'm not sure they're using this. I know they've talked to Evgeny about Southbound Driver. I don't know if they actually use that.
I thought they're not using the Southbound SDK, they're using the other one.
Yeah.
Right?
Yes.
Because it's not even ready, they can't say they're complete.
Right.
So, okay, so that's what I thought, but I think Kurt, you were saying, they're probably using the Southbound.
Yeah. I know they've talked to Evgeny about implementing through the Southbound SDK, but they didn't. It wasn't ready for full implementation, so they just went and did it, and then I guess they'll.
They wrote a native driver.
What's that?
They wrote a native driver, is it?
Yeah. And if you search, in fact, if you search on GitHub, you can find Ceph driver for Copperhead.
I will look it up. I haven't done a good job of looking it up.
Or so I was told. I haven't looked for it myself, but I was told that they have their own fork. So basically, they have a whole fork of Copperhead in GitHub where they did the driver development.
Okay.
We'll cross our fingers and hope that it merges in cleanly when they decide to.
But, so I think ideally, this has been a pretty much a painful process in Cinder community as well, right? You write a Cinder driver, and the question is your driver working correctly or not? Is it really working the way it is supposed to be? Then the second aspect is, okay, is your driver introducing some other side effects? What would that be? So this whole CI, and then when someone is writing the framework changes, whether the drivers that you wrote are already working or not. So there is a need for CI test framework. I know we talked in the last meetup. We haven't done a whole lot of that, but a portion of that CI framework was to look at the OpenStack side of the world too, right? Because, sure, you guys will probably talk about that tomorrow. But in general, it's just not the driver testing, but just the CI. And then how does the driver pull request will be part of that CI scope.
Yeah, so those were some of the suggestions we had with John as we first, I think it's about everybody's time to talk about the southbound SDK. So thank you for your feedback.
Yeah, one more. We have a pull request for skill story and operations. So please, please agree.
We're all going to be around on Thursday.
Yeah.
Okay. I have some ideas that maybe might help the debug process.
Okay, thank you.
So 3 weeks, you'll have pretty much everything done on the scale IO, right?
Yeah, we covered.
Is that?
Many of them mentioned that.
3 to 4 weeks.
3 to 4 weeks, we'll be done with the scale IO driver.
So would that mean the southbound SDK framework will be ready, scale IO will be ready, and we can comfortably say that it is something that works with the new southbound SDK with one driver? Is that after 3 weeks, both SDK as well as the scale IO driver
I
fully
can only
functioning?
say about
Yeah.
driver.
Right
so the
now.
SDK is as advocate, right?
Okay, so you will have the driver implementation ready. You will do
Hopefully.
some amount of testing based on
Yeah.
command line
Yeah.
or through the standard southbound SDK interfaces if it is feasible and ready, but the scale IO driver will be done.
Yeah.
Right. What I'm hearing from their presentation is we've still got some work to do on integrating drivers that are written against that SDK. What I'm hearing from Susie is there's a whole bunch of magic you have to do manually to actually integrate one of these drivers once you've written it, right?
Yes.
And then we also.
So I think someone, I don't know who, should be working on like automatic the deployment. Now it's a manual.
Right, plug-in style
Yeah.
adding of a driver as opposed to going in and tinkering with the build. And then the other thing that we don't have in the southbound SDK right now is scope extending all the way up into the UI, which they kind of hinted at. Right now, the UI knows explicitly about all the different types of storage systems that can be added, and it doesn't have any way to interrogate and say, hey, has a new driver been added? And if so, what kinds of questions do I need to ask about it? And so to get this one actually working, there's some work that needs to be done in the UI to recognize a SDK-based scale IO driver and get it where you can do discovery through the UI and the rest. And so I think there's some moving parts that I'm not sure have anyone actively working on them at the moment.
Yeah.
So
now, maybe this is completely orthogonal question that if you were to look at the scale IO driver, how many lines of code is it compared to the existing scale IO driver?
It's comparatively less. For the
50% less,
I
25%
don't
less.
really
Just
probably 50% less. For the
That's substantial. That's 50%.
Yeah, because for the discovery functions for storage systems, pools, and ports, it's probably around 250, lesser than that.
Lines?
Yeah. Means compared to the previous one, it's around some 75 to 100 lines. It's pretty less than that.
Okay.
I want to say though that let's get provisioning working and then snapshot. Because snap, but we are not doing provisioning. So we create volume and then snap, and that should be the order in which we do things. It shouldn't be, oh, I have created volume through, out of true.
Create volumes and then snap.
Create volume separately, but I can snap through this driver. I mean, I don't think that's, maybe discovery is one checkpoint. I can say, oh, discovery is working, we can check just that part of the code. But when doing snap and clone, that should be based on whatever we have provisioned through this.
Sure.
Okay.
Great. I think that's all we have.
Okay. Thank you.
Thank you.
Thank you.
thank you.
Okay, now.
See if I can get Evgeny. Evgeny is on. He's in the building. Now let's see if we can actually.
Promise you that.
Shady says there will be coffee.
Yeah, there probably is. Do you
Oh,
want to check this out? Okay, go look up front while I'm seeing Evgeny.
He said there will be coffee.
Evgeny, can you hear me?
Yes, hi John. Hi.
Sweet.
Can you hear me?
Yeah, you wanna I don't think so. Do you wanna I'm gonna stop presenting. On the wall some places.
Right.
And then you can share your screen.
Okay.
We need to mute locally.
How I share my screen with this Hangouts? I'm not sure.
This is fine. Don't if I don't hear reverb, I'm not touching.
How are you, Evgeny?
Hi. How I share my screen with?
On the left side, there's a thing. There's a little thing that looks like a monitor, and if you hover over it, it says screen share.
1 second. Hangout. Screen share. Okay. Share. Okay. For some reason, it doesn't. 1 second.
Do you see screen share, Evgeny?
Yes. 1 second. So start screen share.
There we go.
One type of button, like the little bird.
Can you see my PowerPoint?
I could, but it just went away.
All right. I can. Okay. Can you see it now?
No.
One.
Oh, there we go. Now it's back.
All right. Okay.
Are you using Windows or Mac? You're using Windows, right?
Windows. Yes.
Okay.
All right.
When you go into presentation mode, and you hit Alt Tab and go back to your Hangouts, and then you go back to the share your screen, and you should be able to see the presentation mode bit that you can share.
Oh, I've not done this.
Uh-oh. You know what? This is fine. Just use this.
Can you see my presentation mode now?
It's good. Let's just do this.
Okay. All right. So.
Hang on. Give us 5 minutes. People went out to get coffee. So if you hang out for 5 minutes and wait till everybody get in the room, then I'll introduce you. Okay?
All right. Sounds good.
Sorry for the
5 minutes. I will be back to.
You can hear us in the meantime, so you'll know when everyone gets back in the room.
Mm-hmm. Okay.
Evgeny, are you there? I guess not.
Oh, he might be muted.
Is Evgeny still with us?
It looks like he's muted on that. Did you mute him or maybe
I didn't mute him.
himself? I think he was going back and forth, so he probably.
Yeah. I told him it'd be like 5 minutes, so. We didn't run away.
Maybe he went to find his own crackers.
Yes, hello, I'm here.
All right. Yeah, no, we just had a shipment of coffee and some other stuff, so it kept everyone away for a couple minutes. They're still slowly drifting back, so be patient. We'll get this started soon.
Okay, I'm here. Just ping me.
Everyone's moving this direction.
Like large sections of empty time?
Yes, and we'll have to edit that out at the end. All right, so everyone should be able to hear each other. Can you hear us, Evgeny?
And then edit out.
Yes, I can hear you.
Fantastic. I think most of the people have managed to gradually come back into the room. Were you able to catch most of what Shujin and Taylor and the other guys were talking about?
Yes, I was hearing.
For the moment, I was worried about us getting not being able to hear you very well because we had some trouble with the microphones and speakers colliding, but for now it seems okay, so we're just going to go with it. Can everybody hear him okay?
Yep.
Okay, cool. All right, so you're presenting right now. We can see your slides, so feel free to move ahead.
All right, thank you. My name is Evgeny Roitman, and I work on southbound SDK for CoprHD So I primarily drive all work, starting from architecture, design, and I'm doing implementation. So we started this project in September after the first meetup. So in September, I presented a design proposal for the SDK, and first draft of the interface definitions, object model definitions have been presented. Now it's easy for me to do this presentation because we already have working stuff. So we already have SDK partially implemented. We have first scalar driver, which is built on the SDK, and it's much easier to talk when you have something working now. So primary goal of SDK was to kind of decouple concerns. Instead of developers understanding all kind of idiosyncrasies of how Copperhead should work with database, with coordination infrastructure, Zookeeper, with like how it should complete internal tasks. We want to separate this and make it only concern of SDK implementation, and then driver should just take SDK, implement required interfaces. Object model is provided as part of the SDK, so driver should work with this object model, just do translation between object model of SDK to object model of its storage array, and that's all. So all complexity for the driver developer is focused on the understanding physical storage, understanding how to talk to physical storage, and just implement required interfaces. And then testing, it should be simple, because for testing you don't need to deploy Copperhead. You just deploy, you build your driver, compile jar, implement simple test client, and test how driver works. And after that, we plan to have simple automated installation, deployment of drivers into Copperhead, and then maybe do some integration, final integration testing. And it goes well. We have kind of plans for Yoda to release core functionality in SDK. So we release discovery and block provisioning support. Essentially, it includes array pool sports discovery. That's part of discovery. For block provisioning, we support volume operations, create, expand, delete volumes, volume export operations, create export, update export, delete, consistency group operations like create volume inconsistency group, snapshot consistency group, etc. And local protection operations, snap, clone, mirror, which are applicable either to individual volumes or to consistency groups. So this is planned for Yoda release, and it's targeted for April. Okay. So other task for us is to automate driver installation into Copperhead. Currently, we have manual way to install driver. So it's basically like developer needs to know to modify couple XML files to add the driver kind of fully qualified driver class name mapped to storage system type, and then restart Copperhead services to complete driver installation. And that's what we plan for Yoda. For after that, for post Yoda, we are thinking and we plan to have UI-based driver installation into Copperhead. So that means that Copperhead UI will have special service catalog, which will ask several questions about driver, primarily what is, say, driver location, driver jar file location, what is storage system type, And then if it's kind of provider-based or system-based driver, and essentially that's all. And after that, this process will run and it will install it will copy driver jar to specified location for Copperhead to upload its classes, and then and modify several XML files to consume this driver. And our target is to do it in kind of persistent way, so driver installation should survive Copperhead cluster reboot. That means after we install driver, so we install driver and then for some reason we reboot Copperhead cluster, driver installation should remain live. So developers shouldn't go and reinstall it again. I have only like 5 slides, so I go over all of them and then we can discuss. Also, next step after Yoda, we plan to introduce a comprehensive storage capability model into SDK. So this will focus on how to discover and how to use default and custom vendor capabilities on Copperhead. Essentially, default capabilities, it's kind of common capabilities which have well-defined semantics in storage management. And Copperhead provisioning stack integrates default capabilities into internal constructs. So that means Copperhead understands what this capability means and knows how to work with this up to semantics level. But specific vendors may have specific unique capabilities for their storage systems, and for this we plan to support this kind of set of custom capabilities, which essentially are opaque for Copperhead. So Copperhead not necessarily understand what they mean, but it can discover these capabilities, discover their types, and then when it discovers storage system and pools and ports, it also can discover capability instances of storage elements for these custom kind of capability definitions, and then process them, show them in user interface for, say, vpool definition, and then use selected values for these capabilities for vpools and match to right set of storage resources like storage pools and storage ports. So that's essentially pass-through treatment of custom capabilities. So they're opaque, but we can consume them, we can show them to user, we can do some placement based on these capabilities, but essentially we don't understand exactly what they mean. So that's also targeted post-Yoda release. And this slide presents a roadmap for SDK. So we currently in phase 1, which is API for block discovery and basic block provisioning operations.
And we're still seeing the first slide. Are we supposed to be seeing some following slide?
Yes. You don't see. What slide do you see?
Release is what we're seeing.
Yeah, we're on slide 1.
Slide 1. Let me do this. I don't know why it happened.
We're not seeing presentation mode. We're seeing the normal loading.
Ah, well, I understand. Because I moved in presentation mode. You know, I will then use this normal mode. Can you see second slide now?
Now 3.
3, all right, okay. So this is number 2, driver installation into CoprHD.
Okay, and you talked through that one already.
Yes, I already talked about that. Yes, it's like manual driver installed, that what we have now, and that post Yoda we plan to have UI-based driver installation into CoprHD, and the goal is to have persistent way to install this driver so it survives CoprHD cluster reboots. And I also talked about this. This is number 3. Can you see it?
Yes.
So Evgeny, can you go back to slide 2?
Yes, I'm on slide 2 now.
Install the second bullet. What do you mean by that?
So what I mean by that, the driver artifact is jar file. So whatever driver uses inside jar file. So now this jar file should be deployed into CoprHD. So there way to do it through user interface. There should be way to do it through user interface. So let's say CoprHD is running. I go to user interface. I open service catalog screen, install third-party driver, specify driver jar name, location, storage system type, and execute installation. That what it does.
So from the UI, will it be a REST API, or how will it? So this is the.
Yes, it probably will be REST API supported by CoprHD for driver installation.
Okay, got it. I just wanted to make sure it is REST API and you can run it from command line and UI.
No, yeah, it should be API, REST API. And yeah, once again, this is not in Yoda, it's post Yoda.
Yeah. For Yoda, at least the scale-IO driver should be there by default, right?
Yes, we plan to have it by default. Yes, there's only one currently hard-coded place in portal service which we need to add scale-IO driver. All other places, they're XML files, so a couple XML files which we put as part of the Yoda release.
So one question, Evgeny, on, you mentioned with UI, you said it's the catalog services that will integrate with the driver installation and configuration. But essentially the UI has 2 components. There's the catalog services and then there is the element management part. So shouldn't this be more like a system management function as opposed to catalog service function?
Yes, system, yeah, because for me, I wasn't aware about this kind of separation, but right, it's system management. It's not, yeah, it belongs to system management. Yeah. Okay, so slide number 3, storage capability model support. This is a big task which I started to work long time ago. I made a couple kind of design documents, and it's a complex task, especially for like custom capabilities. So idea here is to have 2 types of capabilities. First type is default capabilities. So that's what we already have in CoprHD. We have kind of capabilities which are integrated into CoprHD, and from most cases, many vendors support them. And CoprHD internally knows how to work with them, what they mean, and how they do placement based on these capabilities for storage resources. for storage volumes, file systems. Other type of capabilities which also we will need to process if we want to work with third-party arrays are custom capabilities. So that's capabilities which are not, say, not common to some arrays, but unique for some specific array. And for these capabilities, we want to consume them, discover, consume, enable selection of storage resources based on these capabilities, placement of storage resources based on these capabilities. But we cannot like semantically understand them because they're unique for third-party array, and we don't have internal implementation. We plan to have like pass-through discovery representation of these capabilities, and then using them in provisioning based on some like predefined rules which come with capability metadata, which we discover when we install driver.
So question, Evgeny, on the custom capabilities, what would you do with it? How would you do with it? So for example, you go and discover SolidFire, and it basically gives you QoS, 3 different types of QoS settings, high, medium, and low. What do you do?
Okay, so SolidFire. So what we do, we will discover them. So for each storage pool or whatever these capabilities map to, when we discover this construct, we discover it with capabilities. So we store them, and we know that this is capability name and this is capability value, for example, like quality of service gold. And then on the UI, when user creates virtual pool and specify that I want a storage type SolidFire, then we will show quality of service as one of the parameters of available capability for SolidFire. And then based on the discovered storage pools, what quality of service they have, we will show that there is gold, silver, bronze, for example. And then user selects, I want a quality of service gold. So that goes with a virtual pool definition. When user goes and provision volume for this virtual pool, then we specify in request to the driver that this volume should be provisioned with capability quality of service which has value gold. And then driver understands semantics. We don't. We just know this is capability name which is required and this is capability value. So that's essentially what we plan to do. We plan to discover capability, custom capability, present them to user when user builds virtual pool, and then use them in provisioning to match resources which support these capabilities, and then send it back down to driver, so driver really place this resource on the right, say, storage pool.
So Evgeny, there will be a custom capability storage pool matcher, something like that?
Yeah, storage pools and storage ports, maybe some on the storage system level.
Okay.
Yeah. Yes. Yeah. Each discovery request in driver, even now in the driver SDK in the interface for discovery storage system has parameter for capabilities. Discover storage pools has parameter for capabilities, and the same for storage ports. So when we discover, driver can specify set of capabilities which are name value pairs, name mapped to different values, for example, set of values. So we can discover them. Right now we don't support them, so we say we said to scale your driver, just don't discover them. put now. But as soon as we support them in SDK, we can say just use them, whatever capabilities you have, put them in this parameter and we will process them and we will show them for user selection when vpool is created, and we use them for provisioning. Any questions on this slide?
I think we are good.
All right, so slide number 4, southbound API roadmap. This is a slide from September presentation. There's no change here, but the only difference is that now we are in the phase 1, in actively working on phase 1. SDK already supports block discovery for arrays, pools, and ports. SDK already supports volume operations, volume create, delete, snapshot operations, consistency group operations. And I currently working on expert support in SDK, and then I plan to work on clone and mirror support. So that's the plan, and it should complete phase 1 close to April. And so, yes.
Okay.
Question? There was question?
Yeah, I said, is export support going to be in Yoda?
Yes, it will be in Yoda.
So you said you plan to complete it around April? Is that what you said?
Yes, close. Yeah, in Yoda, for Yoda, it will be completed around April all together. Phase 1. Yeah.
I don't think we'll probably be accepting new code into Yoda by April, so we need to converge on that. But
okay, we will work on this. Then we will need to cut maybe mirrors could go after Yoda. But experts will be there. Expert support will be there before April, which is important. And after Yoda, we plan to work on phase 2 for SDK. It's API for file discovery and provisioning. We need to go over to see if we have any obstacles to support vplex orchestration for third-party arrays, and also we need to support metering and monitoring APIs. So this is phase 2, and it targeted after Yoda. And then phase 3, this is enabling of orchestrations, third-party specific orchestrations for data protection and high availability. It's not clear when we start working on this, but this is on a roadmap. Okay. Slide number 4. I put some maybe candidates for open questions and community projects. So, as I said, driver it's not dependent on CoprHD. The only dependency is it should kind of have SDK jar on class path and implement interfaces and use object model inside SDK. So not clear why we need, how we like, when people start develop drivers, should we have separate Git repository for southbound drivers, or they go to this common CoprHD repository? That's what I think we need to decide at some point.
I know when you were trying to
separate the copperhead into logically separated into a few detailed cores. I don't remember exactly what was decided. I know we said, okay, it makes sense, and then you had a proposal, and
right, we
does that
have.
fall under that scope at all?
Can you, Evgeny, can you hear Reddy's question?
No, sorry, I couldn't hear it.
Asking about, do we have a plan in general for separate Git repositories for different parts of Copperhead? And I think the answer is we have sort of one, in the sense that we've sort of, at the moment, everything that is the core essence of a Copperhead build right now is in one repository, and then there's been some various add-on tools that folks have been offering to contribute, like a PowerShell integration for Viper, and some other things that are sort of peripheral to an add-on to Copperhead. And in those cases, we created a separate repository in the case of the PowerShell window. I don't think it's been populated with anything yet. So we sort of have an evolving strategy of, okay, what should be in the core repository and what shouldn't. I think because southbound drivers are supposed to be separated from Copperhead in the sense of their only dependency on it is in a well-defined set of SDK APIs, it probably makes sense for them to build separately and then be integrated. But I think, Evgeny, we were having a kind of a water cooler conversation after the OSU folks did their presentation, talking about, well, yes, they are dependent on the SDK APIs, but they're also leveraging some other things that are, as far as I know, not technically part of the SDK, right? They're using the REST integration that we had already built for Scale.io. They're using some of the underlying platform services. And so we need to get a better handle on what is the set of APIs that are fair game for these southbound drivers to depend on, and which ones aren't, because along with that, we've got to make a statement on API compatibility release to release. If we're going to promise API stability, we have to know which APIs we're promising it for, and not the entire Copperhead tree.
I know this, and this is my concern, because if they use some libraries, REST libraries, which were built for, like, as part of the other things in Copperhead, this introduced dependency. I prefer that they maybe you copy these libraries and use them independently. It's their proprietary REST kind of client libraries, because I don't. It will be hard to standardize on these things.
There may be a set of tools that we want to provide that are not technically, I mean, maybe we decide they're part of the SDK or whatever it is we provide, but there's some place for some shared tools, but we need to know very well what they are and rule some libraries in and some out, or else we could break any given driver by changing any API and not realize it. So that's you probably need to know.
Yes,
So there is a Copperhead, and there is the driver code, and then there is the storage packet. Three different pieces. So what I have seen in the past is driver code. Sometimes it gets embedded into the base package. Sometimes it is separate, depending on what software you're talking about. So, for example, the Docker guys have most of the drivers outside. But when you put in the volume driver, it explicitly states that it depends on this software, this runtime already up and running before you actually start managing it. So they don't bundle the storage backend APIs, anything. They explicitly state the dependencies and let someone figure it out. So that, because bundling that is good and bad. If you have such a tight dependency, you are better off just bundling, because if you have so much of variation in the REST API on the network side, it's extremely difficult to keep and figure out exactly what it is. And if it is not that obvious on what REST API driver it is on the Scale.io instance, you're probably better off taking the Scale.io driver, southbound SDK driver, and bundle the REST API runtime as well in it, and then package it together. But the packaging is still part of the driver as opposed to really the Copperhead.
My thinking is that some of the drivers, we should have a mechanism so that drivers can be built separately.
Yeah.
We also need to have a mechanism so that from release to release, some of those drivers are pulled into the master branch so that they are shipped as part of your default package. And so, there will be drivers which will graduate from being external to being internal, provided they meet certain criteria. And once they are internal, they by default are then maintained with every release.
So the criteria could be the CI, past certain CI criteria.
Yes, but we are not stopping people from developing drivers which are outside. So for instance, somebody takes Copperhead and he has a way to develop drivers, goes to the UI, brings them in, does all the testing. Let's say 6 months down the line, he thinks, now it's ready to be submitted. Submit to the Copper community. Community will evaluate it, look at the code quality, look at all the test results, and then say, fine, you're in. And then you can be in the master.
Yeah, the problem with that approach is this is where we got burnt in the other open source projects. It is a function of having insight into the storage backend. Assuming that the community has that insight and they can look at the code quality. That's right. You can just run through the standard assertions and say this code looks good and all that stuff. Doesn't mean that it is functionally sound and it is something that really makes sense.
Right, the person looking at code doesn't understand the storage system. Exactly. They don't know if
that has been a pretty much dominant feedback. Because even in the developers have insight into the storage backend so that you have that expertise to say this is a sound driver versus this is not a sound driver, even though it works functionally.
You need a performance tool or something?
Yeah, there was a question about conformance testing, and it just adds more and more scope.
It's too much work.
So they tend to stay away from that. If NetApp guys are going to write a driver, you expect them to figure out that the driver is robust enough for it to be with a certain quality. They can use the CI framework just to make sure everything works together, but it is their ownership to make sure that the driver is sound and it is something that really works and scales and all that stuff. Because there are a lot of other challenges, like failure recovery. Who's going to do it? When you have a new NetApp backend for you to really validate it, you don't have it. So I feel uncomfortable saying that.
But why would you worry about validating NetApp driver?
Yeah, exactly. So the moment you get into the situation where certain drivers will go in, you start creating a criteria on what goes in and what is outside. And so if the criteria is extremely loose, anything that is ready to go and passes the CI, then it's a different thing. If you start actually creating a criteria that is a little bit more on the quality side, it gets to conform to the quality. Because you need to have a CI lab with a specific storage backend for you to really say this quality driver. So the difference between functionally ready versus quality driver, you really need to be very good on defining the criteria to be in of the core or out of the core.
So when we say we want them to do CI, we just want functional. You created it through no exception. The rest of it is their responsibility, like an SDK level test. That's how OpenStack does it.
But Reddy's got a good point. That doesn't mean it's going to work well in a high volume situation.
But is it our responsibility to secure work in high volume situation?
I don't want us to be I don't want the community to be responsible. I want the driver owner to be responsible of all those things. Just because it is part of the Copper, if we do decide that it's part of the Copperhead distro, we have to set a clear expectation. It doesn't mean that it scales. It has, it works for a customer scenario and all that. There natural distro be there and set the quality expectation to get in beyond just functionally ready by just passing the standards.
I think being part of the distro is more a matter of convenience in the sense that you don't want everyone to go through that process to install the driver through the UI every time. Once we
it's a painful process.
Right. It's a painful process. So we presumably want only the developers to go through that process to validate their driver. That's it. But once it is validated, it should be part of the distro.
I mean, the Linux kernel guys do somewhat similar that.
But we need to make a distinction.
Right? If you want your driver, your device drivers to be inbox driver distributed with Windows release,
you need to pass vehicle test. So there is a quality assurance step in the fleet. I'm saying we can't do that in Open. Yes, the corporate community open source. Who's going to do that quality assurance, right?
So I think the way you need to handle this is by having a distinction. It can be in the Copperhead distribution, but there needs to be a way to distinguish drivers in saying that this driver is fully supported, meaning the Copperhead community takes bugs on it, or this driver, which is included in Copperhead, is supported by this other organization that submitted.
Yeah, there has to be a
Could be, yeah.
There has to be a tiered system.
As long as we can make that very clear, it has to be fairly transparent.
It has to be. There are many ways to make that clear. I mean, you have to have, you want it easy enough and frictionless enough so that people will actually submit drivers, but you don't want to make it the process so onerous that they don't want to actually do anything. But at the same time, you don't want, if we release something as part of Copperhead, it can't break so easily. So there has to be like 2 levels of certification. Certification is a bad word. If they're your product managers, hold your ears because they don't like it when the developers use that term. But there's a first cut of here it meets these basic level functionality, and it can be put into a repo, not necessarily the repo. And then once it matures to a certain level, we can have some level of either some level of testing, some level of CI, passes more advanced tests, and then we say, okay, now it's part of our general software collection release. And
so I will challenge that from
that.
So let's say I have a Fujitsu Eternal Saplines.
Fujitsu what?
Fujitsu Eternal Saplines, right? Very, and I wrote a driver, and I'm going to submit that.
Okay.
All your CI will fail because there is no appliance actually behind the scenes to be able to test it.
Right.
So how do you decide whether it should be part of the Copperhead distro or should it be outside? I take the Hitachi, driver. How do you know that it is really working or not?
Right.
I'm not going to give you the simulator. Even simulator I cannot trust. Then just fails. So that's a challenge we are out.
It is a challenge. I mean,
assume that
ideally, those vendors would give us the stuff so we could actually verify.
So that's where we run into all these challenges. Storage, that is the biggest problem.
Side, it is on the vendors. For my driver to be part of OpenStack, I need to have a CI system that gets configured off of check-ins to the main repo that runs against my actual hardware and reports back whether it's successful or not.
I was about to ask you, how do you guys do it?
We've had these exact conversations too, and there's drivers supported, community supported, and things like that. For me, that I've always pushed back on is whether you say it's Copperhead supported or not, for an end user that loads up Copperhead for the first time and tries to describe it, whether it's Copperhead or not, it's Copperhead, and if it doesn't work, a bad experience with Copperhead, it's not a bad experience with vendor X, Y, Z. Might as well.
No, that's a good point. Usability is important.
Yeah.
And there is some implicit certification that I included you.
Yeah, if you get included in the main distro, then the expectation is that you must have done some due diligence, right? You must have tested this, you included it, and you uploaded it.
Yeah, the question is, do you blindly trust? Do you actively test? And do you actively test with your own equipment? Or do you actively test with the actual driver developer equipment, and you have the infrastructure in place to go beyond the firewalls and make that happen?
Right. And different projects will have different commitments to that. So we host some whole join test infrastructure here. And yeah, part of that is we have a whole bunch of cell phones hooked up to a bunch of Jenkins nodes, and they hammer at it.
I mean, it's very similar, right? If you look at the Microsoft, if you look at the Microsoft Visual Testing or VMware certification, it's all about either doing with the real equipment with the VMware person on board and checking off saying that it meets the quality, right? Even the SNIA, SMIS compatibility thing, all that stuff in the devices, it's all about checking off someone owns that. Really careful.
Right.
In our case, at least for the short term, it's going to be a very significant
I mean, but in that case, I mean, what I would suggest is be very careful about what you bundle in your actual fixture.
Exactly.
Because
Exactly.
if I install CoprHD, CoprHD works, I gotta go to Fujitsu to download the driver.
Exactly.
It's clear to me that Fujitsu owns that.
Yeah,
what if? I think the default is you keep it separate to start. I mean, then you have to come up with this criteria.
Exactly.
Then we can pull it in.
Yeah.
Once we have the infrastructure and the whole way of.
And that can be kind of a carrot we dangle for them to participate, right? Like, oh, we'd love to include your driver, but, you know.
Well, it could be as simple as the vendor has to give one piece of the equipment to pull it.
To where?
Whom do you give it to?
It goes to Shane's lab.
Maybe Shane.
I'm in favor of that. He's not here to defend himself, so we'll say yes.
Let's say yes. Yeah, this room's pretty big. We could just start stacking. Yeah. So I think those are the things, nagging things that need to be addressed.
Yeah.
Minimum viable functionality. That should be one set of checks.
It has to be like a unit test
The
level.
second one
is
is
it has to be all these things.
the testing against the actual drive.
Yeah.
Third one is they have to submit something so the CI works even beyond the vendor, like simulator. Right?
Yeah, I mean, it could be, what I'm saying is there has to be a very transparent way of inboxing the drivers versus being outside. Either it is completely loose where anything that is just ready, where you really can't afford to test. You don't know whether the function is really even functionally ready. But it is part because someone made a pull request, someone reviewed and it's good, put it in. Okay, it's part of, it doesn't mean it is even functionally working. Because you can't test with real equipment. We don't have that in our
Right. So couldn't we have a driver repository somewhere?
Yes.
And a driver browser, essentially inside. So you say I want.
You make an app store also.
I mean, not just. So essentially, when you're ready to go, you go into CoprHD, go on a page, and then that basically makes a call somewhere, and then once that happens, you can download whichever drivers you want.
Exactly.
But at that point, you're downloading specifically, and it's all done from inside.
Yeah. So, but the decision is actually by the end customer.
Right.
As opposed to you forced into bundling with CoprHD based package, thinking about all kinds of innovative ideas to say, hey, this is really in but may not be working. Oh, this is in but I certified to my arts content.
Well, we
so
can
rather than actually going into that level of
with that approach, you can still have certified and non-certified available, latest work in progress, whatever.
Exactly.
And as long as there's some place, as long as there's a group of things bundled under a category that says, this is broken, you know, use it at your own risk. I mean, that's
something like that. Yeah.
We have to be clear, like which parts of the
Linux college experimental.
Yes. I'm sorry, you had a question? What?
No. I was going to say that it might not be a good idea to get the vendor's hardware and everything because then you have to keep it there, power it, heat it, cool it.
Oh, I don't want to do that. I want them to like use their hardware on site to test. Yeah.
On their own site.
Yeah, exactly. Because they should be doing that anyway, right? I mean.
So,
they can do desktop upload and
they do that automatically as part of the build process? Yeah. That seems really cool.
Every patch that gets submitted, you can subscribe to that event stream. So kickoff, new patch coming in, pull that down, load it up, run against it, and make sure that that didn't break anything, even if it wasn't related to your code in any way. Make sure it didn't change some behavior that the person submitting it doesn't even notice.
So is it done pretty much routinely? I know I heard, HP does that because it's while CI setup and maintenance is an extremely it takes time and energy from resources and resources needed. So are all companies doing it or only selected ones?
It is a requirement now, and in the last release, we actually removed several drivers because they weren't able to get a state one. So it can show that their driver was working right.
It's not part of it.
It's not part of the distribution.
That makes perfect sense.
And they're still non-voting, right, in the Jenkins, so it doesn't.
Right, it just has to comment saying, yes, we ran and worked, or we ran and something failed. And you get false failures.
But people can see, like, if this driver failed 5 times in a row, then there might be something wrong with that driver now from that one patch.
So the ones that got removed, either they weren't running at all, or you could look back in the last weeks. asking constant, software running against anything.
Okay.
So,
And basically, somebody's job, in each one of those companies, somebody's job is to set up an app, get this thing running, keep it running.
The good thing about that is like you don't get companies coming in and just doing a dump and run on a driver, right? To say that they're supported, right? Yeah. I support OpenStack, here's my driver, and then they just disappear, right? Yeah. They have skin in the game, they have to support next.
So for the single driver for Viper, we set up the CI system. So, I mean, I know how it works. Basically, any code change in the master, you test it on your driver. Essentially, you're not testing your driver, you're only testing that particular code change. Sometimes people introduce code changes which break your driver. So the idea of that thing is to test that scenario. It's not really testing your driver, really, but it's testing every new patch to make sure that patch doesn't break your driver.
Yeah, and it's one of those things we want to do also. Haven't been able to get.
Yeah, I don't think we are at that level of influence where we can get that.
Okay, so this is your last slide, Evgeny?
Yes, that's the last slide.
Okay, so I think we talked about this a few times, right? I don't know. Ingesting the existing drivers is also an extremely important activity. Here is the reason why, right?
What do you mean by ingesting the existing driver?
Yeah, I will explain. So I think for the past 5 or 6 months, we have been talking to a few storage vendors. And the point is, the discussion goes like this. Hey, I already wrote the Cinder driver. Why should I write a CoprHD driver? So the motivation for the storage vendors to write something native in CoprHD, something that uses southbound SDK at this point for the next X amount of time is going to be low. So we can't be sitting in a situation where, hey, the southbound SDK only works with Scale IO and maybe Ceph because one of us wrote it and then the buck stops there, right? Ideally, what we would like to do is figure out a mechanism to ingest the existing Cinder drivers, Manila drivers on the file, vVol drivers on the VMware side, SMIS drivers on the Microsoft side. We'll be in a lot better situation in terms of making traction with the real customer pull. So what happens is you go to the storage vendors, they're not going to write the drivers. You're not going to, it's not going to be that easy for us to go convince them. It's going to be severely challenging to write the native drivers to start with. And if you go to the end customers and say you want to use CoprHD, the first thing they would say is, hey, I have the VMware environment, I have Microsoft environment, I have maybe OpenStack. Your value prop is that I can manage storage resources and service these 3 orchestration stacks. We can't do that because there are no drivers. So it's like a chicken and egg problem. We really need to go figure out what is the best way to ingest, even if it is a scale down, cut down functionality, we have to figure out a mechanism to ingest 100+ drivers out there in Cinder, maybe somewhere around 10 drivers in one.
Do we have that already?
Lots of SMIS drivers.
How is that different from
Cinder southbound? We already have a solution, right? We can use Cinder as a southbound solution. That solution we do have.
Yeah.
So before we did that, we evaluated this idea of taking the Cinder driver as it is, right? I mean, that was the original idea. Cinder drivers are written in Python, right? We have Python as part of CoprHD. Why can't we simply use that driver?
Right.
The problem is that every driver includes some libraries, right? Different drivers, like the same problem which Eugenie was saying, that they include some libraries they found in Oslo, or they found something in Cinder, they found something in Nova. They happily include it because they don't want to do it, because it's there in OpenStack, right? That library includes some other library, and that library includes some other library. So essentially, if you have to run a Cinder driver, you end up including all those Python packages. Essentially, it doesn't work.
Yeah. So that's not a technical challenge. Yeah. But you have to look at it from the perspective of what does it take for us to make progress with Copperhead in the industry. So, one side we are sitting there and say, vendors are not coming and writing drivers, and they're not standing in line to write the drivers and go through the certification process. The other side, customers are saying, unless it works with the existing stacks that I already invested in, what can I do with Copperhead, right? We have to figure out a mechanism to enable it. I know there is technically a challenging task, but unless there are hard showstoppers that we really cannot do it, then we are at a dead end situation. So we'll have to wait for all these storage vendors to come on board, and we'll have to wait for several years or several months, whatever it is, right?
I'm still not getting it. Don't we already have Cinder driver?
We do have a solution for Cinder. We don't have a solution for Manila or B-Wall or what are the other things you said. We can't ingest all of those drivers.
We'll have to go look at what it takes to do it, rather than saying we cannot.
No, I mean, I'm not saying we cannot. Today we don't have that ability.
Exactly. So if we agree that ingesting the existing storage drivers is directionally the right step to do, then we can go figure out what does it take to do it and what would be the challenges, what would be the gaps and all that stuff. For me, I'm struggling because in the developer meetup first time, I was all completely on board with this, right? Then you go and talk to the storage vendors, and we had numerous discussions. You go and talk to the end customers. They're like, "Okay, I wrote the driver. Don't make me go through this certification process. I'm not going to do that." For them, it is a chore as opposed to really because if you were to look at most of the storage vendors that are going to write the drivers, their future, their focus is going to be OpenStack, and that's what they're betting on, right? If they have to support something in VMware, they're betting on VMware. They're betting on Microsoft. There is enough certification that happens among those three big focus areas. And we are here as the fourth one, and we are trying to say, hey, you need to go through the certification on this one. Either we have a compelling reason and justification to make them actually, they see the value and they jump on board and do it, then it's fine. I'm not seeing that today. So
I think southbound, there has to be multiple solutions. Native driver is one of them.
Native driver should exist. I'm not saying we should not, but we also have to look at how do we support the existing
other drivers.
And just a question around that. I mean, you would be happy as long as you had a driver, even if it wasn't optimal, right? So even if you lose performance, if it's not a native driver, you have to emulate, you have to translate, you have to do whatever. You were talking about bringing in a ton of libraries.
Yeah, so instead of bringing in libraries, what we did was, let's use Cinder through the Cinder API, right? And then you have Cinder drivers. So that way, indirectly, we are using all the Cinder drivers.
Yeah.
So today, if you have a Cinder driver for any array, let's say Fujitsu, right? Fujitsu is a very good example because we actually tested with Fujitsu. We don't have a Fujitsu driver. For some customer, he wanted to use Copperhead and he wanted to use Fujitsu. He was very fixed on both. We said, fine, you have Cinder driver for Fujitsu, use it. And that actually worked. So that way, any array which as long as it has Cinder driver can be used. So, I mean, that's the solution. That's a possibility. That's not ideal because, a lot of the functionality like discovery and all that is not supported. Well, it's a non-optimal solution in the sense that a lot of the stuff that, for example, Eugene is implementing in terms of discovery and all that is not there in the Cinder drivers.
But you could also argue that it's not needed too.
Yeah, so
right?
so yeah,
The flip
so
side
we
is
can
that,
say
hey,
it's not needed.
I haven't.
But it gets you in the door, right?
Yeah, it gets you in the door.
Exactly.
You can create volumes, you can delete, you can do all the basic.
The critical 80% of the operations are
available.
True. You go do whatever you need to do, all the setup. I don't care. It's whether automated discovery or manual setup. If people are happy with the manual setup in OpenStack, you don't force them to change their behavior overnight.
Absolutely.
And then you say, hey, create a volume. I can create a volume. You don't need to write a driver for me to create a volume. By the way, you can't get discovery, tough luck. You can write the native driver. Yeah. But you put your foot in the door, and then you actually convince them to write. If there is enough compelling value prop, they will write it. And so over the course of time, there may be.
And if you keep track of how many people are using these suboptimal drivers, and can report back to Fujitsu and say, look, you've got 10,000 installations with this and suboptimal, your users would be a lot happier if you wrote a native driver, then they got some data points.
Exactly.
So my question's about what? Did the customer deploy that solution?
No, they did not.
And why not?
That was for other reasons.
There you go.
Not because of lack of discovery capability.
No, there are issues, there are challenges in terms of how easily you can deploy that kind of a solution.
Are you asking about the Cinder runtime and driver combination, or are you talking about something
I'm
else?
asking if viably customers will actually deploy those solutions and feel they are supported. That's what I'm asking.
Because you have the issue of, okay, so that driver is written by Fujitsu, right? And Fujitsu will support that driver as long as you're using it in OpenStack environment. However, you are using that driver in a different environment and they may not be willing to.
It's the customer that decides at that point. It's not Fujitsu, it's not us, it's not CoprHD community. Because if customer A comes on board and says, I want to use it, go get your act together. CoprHD, I want to use CoprHD, you will ingest the Cinder driver and be able to manage your app plans. Get your act together. You have a choice either to support it or you write it to the code. True. Both options are on the table. You decide. But there is a customer pool that you are creating, and a demand is what you are creating.
But think of a developer. If this thing doesn't work, they say, okay, so forget. Unless the developer has, somebody at the top saying, yes, we need to, or somebody.
That's why the customer has the pull in that situation.
So the customer, so you still have to influence somebody there. So go ahead and do that. Or if the developer at that point saying, okay, I'm going to that makes the decision.
The developer won't do anything until he's told by his marketing team who gets the customer up from a phone call, right?
Yeah, so when CoprHD has reached that position where people say yes, so how do
Then
you
it's a
reach
different
that?
thing. Yeah. The question is, how do you reach a tipping point before you can start?
Okay, to rein
Maybe
this,
that is a norm.
to rein this in a little bit, I put driver ingestion on our parking lot.
Yeah.
And
Yeah.
so probably we should take a break and then get ready for the next
Okay.
session, which I think is supposed to start in about 15 minutes. Is that right?
Yeah.
And we have people off-site that are participating, so we want to.
Take that one.
Is that the Docker one or
Yeah, we can do the Docker one, and I know you want.
4:30?
Yes.
Can you dial in at 4:30?
Yes.
So we have time then.
I thought you had a set one for today. Is there a set discussion?
It was open storage, I think.
Well, thank you, Evgeny.
Open storage.
Yeah.
Thank you, Evgeny.
Thanks, Evgeny.
Thank you. Thank you.
Okay, this brings a close to the streaming for now, and then we'll pick it up again tomorrow at 9 a.m. Pacific.
We're not streaming the last presentation.